Hello all, this is VLSI updates. Hope you all are doing well. And I just thought of covering this session to give you the basic introduction about the bus protocol, mainly into AXI bus protocol. If you take any typical SoC and you see the interfaces and the communication between the different IP blocks in any SoC. I mean, in in general, in generic SoC, if we take the communication between the different IP blocks, needs some standard to communicate. Uh, the communicate between them. Let's say if you have some IP and you need to IP can be developed by individual owners, individual designers. Okay, so when you want to use this IP in your SoC, you need to have some standard interface which will help the other designer to interface with the other blocks in an SoC. So that is where the standard has come into the picture, and IP will be developed by different owners. So they have to standardize how that particular block can be used by other designers. So in that case, the common interface for any IPs, and if you take the AXI bus interface, and nowadays all the IPs are coming with the AXI interface defined on top of that. So it's just like we need to create a wrapper on the conventional IPs, so which can be used across the in a common way. It's a kind of common interface, and which can be used by other designers as well. So that's a key point here. So here I'm just showing one basic SoC design, how a typical SoC looks like. And you can have one CPU processor, like it can be ARM based, or generally in mobile SoCs we see the ARM based processor over there. And there is another two blocks. So there one is a DMA core, direct memory access, and the other one is a DDR memory controller. So this will talks to the external DDR memory. So these are the basic blocks. Apart from that, you can have many blocks, depends on your SoCs, and you can have multiple IPs, and which has to communicate to the processor somehow. Okay, so in this case, if you take the processor is connecting to the AXI bus. This is AXI bus. So if you look into this, so this should be also the AXI interface here. Okay, and we have the DMA core. This is also connecting to the AXI bus, and we have the DDR memory controller, and this is also communicating to the AXI bus. So in this case, the CPU is the one will initiate the transactions. Let's say like the CPU wants to access the DDR memory, so the memory will be placed somewhere outside the SoC, which is the physical memory I'm talking about here. So let's connect the memory somewhere outside here. If you connect your memory here, let's say my okay, let me not put this. Yeah, so if you see the real-time memories, you can see like a slot. Okay, RAM memories or the ROM memories. So DDR also will have a slot like this. Let's say I want to access this memory from the CPU, right? So the CPU will act as a master, and the master is the one we will see like what are the different communication channels are there in the AXI AXI transactions. So that will give us more clarity on that. Okay, here I'm just talking about general. CPU will act as a master, and CPU will initiate the transactions. The transaction will be requested through the memory controller, and memory controller will communicate with the physical memory. Okay, so this is the actual DDR memory interface. You can see it here, and this is the AXI interface here. So the if the master wants to write into the slave, so the master will initiate the write transaction. The CPU will initiate the write transactions, and start writing the data into the memory via the memory controller here. Okay, so if you want to read the data back, the CPU has to initiate the read transactions. When the read request is initiated, the memory will start communicating to the actual memory, so you will start reading the data back from here. So it's kind of cycle here. The CPU can initiate the write request, and the controller will start writing into the data into the memory, and the CPU can initiate whenever it is ready, it can initiate the read request. Okay, so the data will be start reading back from the memory, physical memory. Okay, so DMA core is something which will act as a processor, and it also will directly can communicate to the memory via the DDR memory controller without the CPU intervention here. Okay, it will be used like a backdoor access kind of thing, and some critical situations where the CPU might be busy in some other tasks. So to unload the CPU, DMA can directly access the DDR memory. Okay, and it also has to communicate to the AXI bus here. Okay, so so here this is the master, and these two guys are the slave here. Okay, so but these two can communicate between this here. Okay, now we can see what are the different channels out there in the AXI buses. Let me go here. So basically, like if you take AXI, any protocol, if you take, there should be a master and that should be a slave. Okay, so in this AXI communication, you can see different channels. Okay, each channel will have its own signals, and if you go into the right address channel, which will have the address related ports. Okay, it has to communicate to the slave. Okay, and write data and the write response, and the read address and the read data. So basically it called like write transactions, and the master will initiate the transaction to the slave and start writing the data into the slave. Okay, it can be a memory, it can be any other IP also. The job of the AXI master is like initiate the transactions, send the address and the corresponding data. The slave could be the DDR memory, the slave could be any IP, any standard IP, it could be anything. It doesn't have to be always the DDR memory controller. Okay, it can be any common IP. Master also doesn't have to be the CPU all the time. You can have any common IP. We just have to do the communication between this master and slave. Okay, as long as it follows the standard protocols, it can communicate with any slave here. Okay, so in this channel we have the right address and the right data. This is called write transactions. In the read transactions, again the master will initiate the read request and pass the address accordingly and start reading from the slave. This is called read transactions. How does this work? This write transaction and the read transactions. The AXI basically works on based on the handshaking mechanism. Okay, and it always has to monitor the slave status. So based on that, the master can initiate the transactions. So there is a valid and ready. Whenever the slave is ready, the master can initiate the transaction to the slave. So it's always the master who has to make the decision here, and in the right response, the slave has to communicate back to the master by saying that the transaction is completed successfully. It's kind of acknowledgement over there, and with that this master can understand the slave status over there. Okay, so this is the basic handshaking between the master and slave in AXI communications. And for the practice, we can have something. What are the signals stored there in that? If you open any typical Vivado, you can find it out. Lot of AXI based IPs are there. If you open in any of the channel, what are the different signals are used in each channel, or you can refer any standard AMBA specifications to understand each signals are used in the AXI. So let's go AMBA specification. If you go into the AMBA specification, we can find the AXI, AHP, APB and all. So if you come here, there is a AXI protocol specification, and you can download this PDF. Yeah, it's downloaded. Scroll it down, you can see the different channels over there in detail. So this is the basic the channel architecture, the transaction channels, how does the address and the data can be sent. Okay, see, if you see in this case there is only one address and you see the multiple datas are being sent. This is called burst transaction. Okay, and once the transaction is complete, you will get the response from the slave side here. Similarly, for the read also, you can initiate one address and you can get multiple number of data. So it depends on the burst size you set. If you look into the each channel description, you will find many signals over there, and each channel describes about this. You can have multiple managers, I mean multiple masters and multiple slaves, and you can rotate this interface, I mean this selection between the master and slave. You can have the multi-master and multi-slave communication, and based on the address selections, it can communicate to any slave available here. So for that case, we need to have some interconnect kind of thing. So there will be, this will be the master, and it will connect to the slave of the interconnect. Again, this will be the master, and it will connect to the slave of this interconnect. So this master can access any slave which are present here. So based on the address selection, you need to select which slave you want to communicate. So this interconnect will map things accordingly, so you can communicate to the particular slave. At the same time, you can communicate with only one slave, but you can the idea is like you can connect with any of these slaves. This master can connect with any of these slaves. At the same time, you can communicate with 3 slaves at the same time in parallel, because we have the 3 masters. You can connect with 3 slaves at the same time. Let's see the signal descriptions. Yeah, so in each channel we have the different signals. Okay, so mainly the valid and ready signal, and if you take the address right channel, in the right channel we have the right request. Let's go to the not this one. Okay, this is the right address channel. The mainly the address, we are going to see the valid and ready and the address signal. And And we have other signals also, like the burst I was talking about, and the transaction size, and the length of the data you want to pass. How many bit of length of data you want to pass. What is your burst size? Each burst can have many bytes of data. It defined a burst. I think it's a burst type. I need to choose the burst type. The key point is like the ready and valid. This will do the handshaking in between the master and slave. It will be checking the slave ready. The ready will come from the slave. Whenever the slave is ready, the master can send the valid data. Master can accept the valid and make and ensure the handshaking thing over there. After that, it can send the valid data to the slave. Okay, that's a key point. So these are the different features. What is the size? What is the burst length you want to connect? You can set it up, all these things. So there are other features. You can see many signals are there, and you can choose based on your application. You can leave the remaining signals unconnected also, it won't impact anything. So the main features, you can start using it. What is the length you want? And I mean, like once you send the first address, how many bit of data you want to transfer. That's a transfer length, and the transfer size, and the burst type. These are the basic use cases in that. We have the right data. In the right data, again we will have the separate handshake here also. Each channel will have the separate handshake over there. So based on that, you can start sending your data. And the right strobe will be there for each 8 bit of data. There will be one strobe bit. And right lost, it will indicate the lost data. Okay, and yeah, I think remaining things you can use it as per your need. So this will be like doing the handshake and pass the data across your channel. Okay, it will act independently. Okay, so right response, the slave will send a response to the master. So in this case, it will be reverse. The slave will wait for that. The slave will send the valid signal to the master. So this will be happening in a reverse direction in this case. Similarly, for the read channel, see, all these channels are independent. Okay, so it depends on, like, once you send your write address, once you start writing the data into your memory, you don't have to wait for the next write to happen. Okay, so once some data is available in the memory, you can initiate your read transactions. You can start reading the data from it, because the channels are independent now. And you can initiate your read request based on the address selections. It will start reading the data from the memory out there. Okay, so you don't have to wait for the write to complete. Okay, write can happen in parallel, read can happen in parallel. Only the write address and the write data will be in sync. Okay, because you need to initiate the address. After that, the write data has to the write data channel has to act on that. For the read also, the read address and the read data. Once the read address is issued, you can start reading the data from the memory in that case. That's a basic idea here. And we have the read address and the read data channel here. Similarly, it will have the valid and ready signals, and what are the different features you wanted to use. Read data with and response. Um, One of the key point is that, yeah, we are seeing a lot of additional signals in this spec. But if you go into any of the, if you open any of the Vivoda based designs, and you can see the actual signals are used, and the naming conventions are also important. Let me open. Between the master and slave, the naming convention also is really important. And the key point is, like, the master has to initiate the transactions with the help of the ready and valid. And if you have the AXI based slave, you will always get the response from the AXI slave based on the ready. So based on the ready, you can initiate your valid signal. And once you initiate your valid signal, you can always start sending your address and the data over there. Any slave will work on that basis. Let me just go here. You can find many AXI based IPs in this environment. In the Vivada environment, you can find many AXI based IPs. And for the Jink, yeah, you'll have the communication between the PS and PL that will happen through the AXI interface. PS will have the Cortex based core and the PL will have the FPGA based logic. So this communication happens through the AXI based interfaces. So most of the IPs are coming with the AXI uh, uh, interface, which is flexible. If you look into this, we have many AXI based IPs here. Okay, so AXI stream and the AXI memory map. The channel we saw mainly for the AXI memory map. AXI stream is the low features, and this is only for the data streaming, which doesn't have the much features like the AXI memory map. Okay, so you can pick up any of the IPs and you can see the different interfaces are available there. And AXI BRAM controller, and so we'll have the AXI interconnect when you have the multiple master and multiple slaves. I mean more than one master, more than one slaves. You have this interconnect, and you can connect many masters. In the block design, you can have your block also. You can have your RTL also can be connected directly here. So if you see this side, we will have this. If you go back to your SoC diagram, if you see this, you can assume this as an interconnect here. Okay, because I have only one master, but I have two slaves here. You can assume this as a interconnect here, right? So in this case, so this will be the master, and this is connecting to the slave of the interconnect. That's what you will be seeing here. So I have a master here, CPU master here, and this will be connecting to the slave of this AX interconnect. So if you open this slave interface, you can see the tag with slave, and AW means write address. So it's a write address channel, and which will have this following signal: address, length and size, burst, lock, cache, protection, quality of service, valid and ready. So these are the basic signals will be used. Okay, you can choose the signals like the valid and ready. As I said, this is the key signals for the handshaking mechanism here. Okay, this will be coming from the slave side, and the master will assert that here. And then you can start sending your address, the length of the address, what is the size of the burst you want to do it, what's the burst type. um, those options you can select from here. The remaining signals, based on the spec, you can leave it as high or you can leave it as unconnected. Similarly, if you look into that, the naming convention for the data, it's just a data, write data, and strobe, valid and ready, just 5 signals here. Just ensure this handshaking is happening properly and send the data accordingly in that case. Okay, so you have to wait for the ready from the slave. If your slave is active, you just have to monitor this ready signal. Whenever the ready is available, you can start sending your valid data. The address has been already issued, and the burst type is already been issued. So this will be taken care by the master, because the master is already having the settings like the configurations, like how many bursts to be sent for each address, right? So once the address is initialized, and the right data channel will be ready for you to send the data. So once you initiate your valid, this valid has to be valid till the burst type is end. So based on the burst type, you can keep this valid active. How many data you want to write continuously for the single address location, for the single address issued, right? So when I say the single address, okay, the single address, it can be incremented. Just go back to that. um, when I have the single address, let's say, I'm trying to write into this 800.1004 location. Okay, I will issue this one address location. Okay, and expect it to happen for in an incremental fashion. Okay, so I want to send 4 bursts of data. Okay, so in that case, my next address issue should be here with 8. Okay, so which means like I issue this address location 4567. So the incremental fashion will happen in each address locations. I will be writing the burst of data. The burst of data could be it depends on the burst size. It could be 8 bit of data, right? So each address will have the burst of data here. So I can have the burst 1, burst 2 like this, right? So the size and the length of this depend on the parameters you set. And also this burst transaction type, it can be the incremental, like it will increment automatically. You don't have to tell the master, you just have to set the burst type, and once the burst type is set, it will start incrementing accordingly. Okay, so once the 4 transaction is completed, it will automatically issue the flag saying that the transaction is completed now. So that's the beauty of AXI in that case. Just have to configure the master and slave. So based on that, you can see the transactions over there. It's really interesting. And yeah, so in this case, we have the two master in the interconnect. When I say the master, it's an interconnect master. Okay, so here you will have the slave, here you will have your master, and in this case we can connect 2 different slaves here. Okay, so when I say that interconnect, this is the interconnect, and this is my CPU master here, and these are the slaves here. Similarly, like I'm connecting my master to the interconnect and the slaves to the other end of the interconnect. So ultimately these are the slaves. If you see here, this will be the master, but this is basically master to slave configuration. Okay, yeah, similarly you can look into any of the IPs, AXI based IPs, and you can start connecting um, with the processing system, and you can start using the IPs and start writing a simple test bench for any of the IP, and start seeing the trend. This is the best way to get started with. And if you pull out any of the IP and you can start a simple test bench for that, you can make this IP to act as a master, write a simple slave test bench for that. Once you write a simple slave test bench, you can initiate a transaction from here. I think there is a AXI traffic generator. If you go into that, you can use that for the learnings, and can generate a traffic based on the it will generate a traffic for you basically. Okay, it will create a traffic based on the configurations you are providing. I think you need a master for this also. You can pick up any of the AXI master IP, you can start generating the traffic for that. It will create some random traffic, you can connect it to the slave on the other side, just to simulate it, and you can see the simulation also for the same in that case. Yeah, so this is the basic reference that you can refer to from the Mamba specifications. You can have other documents also for APP and AHP, and all you can find it in the same site. That would be really helpful. And also there is a community forum also for the questions, and you can always connect with this community forum. It will just log in the forum, and you can start posting your queries when you are working on AXI. If you come across any situations, any locking situation, the transaction is not happening, or timing issues, or like you issued the valid, but the data is getting 1 clock cycle delayed or 2 clock cycle delayed. Those are the minute informations. You can get the clarity from the community forum. You can make use of this, right? You can just log in yourself in that case, and you can just start posting your queries here. that would be like more learning in that case. Okay. Yeah, I think hope this is helpful and we can stay connected more on this topic. And yeah, comment below for any of your queries in this case. I'll be happy to answer to that. Thank you all. Bye.